This is Dr. A classes for BTech Civil Engineering students. This lesson introduces the concept of wind erosion. It is designed to provide BTech Civil Engineering students with essential geological knowledge. Learning objective of the course is defining wind erosion and explaining its significance, identifying the causes and factors influencing wind erosion, describing the processes of wind erosion, analyzing the environmental, agriculture, and engineering impacts of wind erosion, discussing natural and artificial control measures for mitigating wind erosion, evaluating engineering geological strategies for erosion management. Understanding wind erosion. What is wind erosion? The process of detachment, transportation, and deposition of soil and but sediment particles by the action of wind is basically wind erosion. Forces involved are wind velocity, air turbulence, surface roughness, soil properties, that is texture, structure, moisture. What is the scale of impact? From small scale removal of topsoil to large scale dust storms affecting air quality and visibility. Causes of wind erosion. Strong winds exert shear stress on the soil surface, leading to particle detachment. Loose, dry soil is more susceptible to erosion due to the lack of cohesive forces. Lack of vegetation cover increases vulnerability by reducing root binding and surface roughness. Human activities such as deforestation, overgrazing, and poor agriculture practices exacerbate erosion rates. Factors influencing wind erosion. The factors are climate, the primary factor, aridity or the region with low rainfall, high wind velocity, strong seasonal winds adversely affect wind erosion processes. Soil properties, dry loose soil with low organic matter, fine texture, silt, sand and poor aggregation are more susceptible to wind erosion. Topography, flat open area with little vegetation or obstacle to reduce wind speed affects wind erosion. Land use, deforestation, overgrazing, improper agriculture practices, example tillage in the direction of the wind, also affect wind erosion processes. How does wind move soil particles? Wind transports soil particles from the Earth's surface by three distinct mechanisms known as suspension. Fine particles, clay, silt, etc., are lifted high into the air and carried over long distances as dust cloud. Saltation, medium-sized particles, fine sand, etc., bouncing along the surface in short leaves. Surface creep, large particles like coarse sand or gravel rolling or sliding along the surface. The following picture clearly depicts the movement of soil particles by the wind. Geological work of winds. Wind erodes the Earth's surface by three distinct processes known as deflation. Deflation is the removal of loose or fine-grained particles. Abrasion, the wearing down of surfaces by the grinding action of the particle moving with the wind. Attrition, mutual collision among resulting in the grinding of the wind-borne particles while traveling in suspension. Deflation. The loose soil and dust-sized particles of rock from the area are lifted up and swept away by the blowing wind. This results in removal of fine particles and hard and compact rock masses remaining in their place, which is again exposed to further erosion. Wind deflation can successfully operate in comparatively dry regions with little or no rainfall and absence of vegetation. If the earth's surface is moist due to rainfall or if it be covered with vegetation, its constituent particles are firmly held together and therefore find no chance of traveling along with the wind blowing. Abrasion. The loose particles traveling with the blowing wind tend to collide with the exposed rock masses. Such collision causes a grinding effect upon the rock surfaces with the production of new rock particles which also travel with the blowing wind. During such impacts, the impinging wind-borne particles are in their turn reduced to further fineness. The abrasion process depends upon the velocity of the blowing wind, the relative hardness of the rocks, and the attacking particles. Due to this, the exposed irregular surface of a rock mass is gradually converted into a plane surface which may sometimes be smooth and even polished. Attrition. The process of size reduction through collision is called attrition. The process involves wind suspension. Fine particles like silt and clay are lifted and carried aloft by the wind. Constant collision turbulence causes these suspended particles to repeatedly collide among themselves. Grinding action. Each collision acts like tiny sandpaper wearing down the particles. Size reduction. Over time, particles become smaller and smaller and more rounded. Structures formed by wind erosion. Wind, a powerful sculptor, shapes the Earth's surface into diverse and fascinating landforms through erosions. These wind-carved structures offer a window into the dynamic relationship between wind and terrestrial environment. Some of these structures are yardungs, ventifacts, mushroom rocks, loess deposits, and sand dunes. Yardungs. Yardungs are elongated, streamlined ridges formed when wind erodes soft rock, leaving behind harder, more resistant rocks. They often resemble the hull of an inverted boat with a steep windward side and a gentler leeward side. Ventifacts. Ventifacts are rocks that have been shaped and polished by the wind-blown sand. The sand acts like sandpaper, creating smooth, flat surfaces and sharp edges on the exposed side of the rock. Mushroom rocks. These are rocks that have been eroded more at their base than at their top, creating a mushroom-like shape. This occurs because the wind is more effective at eroding the lower part of the rock, where it is closer to the ground and exposed to more sand. Loess deposit. Loess deposits are thick deposits of wind-blown silt and clay. Loess is often fertile and can support agriculture, but it can also be susceptible to erosion. Sand dunes. Presence of any barrier across the direction of flow of wind causes the development of a zone within which the velocity of wind is much reduced. Such a zone is called wind shadow. Depending upon the occurrence of obstacle, the sand dunes are of the following kinds: Barchan dunes, linear dunes, transverse dunes, and parabolic dunes. Barchan dunes. Barchan dunes are crescent-shaped dunes with the points of the crescent pointing in the downwind direction and a curved slip face on the downwind side of the dune. They are formed in areas where there is a hard ground surface, a moderate supply of sand, and a constant wind direction. Transverse dunes. Transverse dunes are large-scale sand ripples forming ridges with a steep downwind face. They are developed where sand is abundant and wind direction is constant. Increased sand supply can cause Barchan dunes to transition into transverse dunes. Linear dunes. Linear dunes, longitudinal dunes, or sieve dunes are one of the most striking and distinctive types of sand dunes found in the desert around the world. They are characterized by their long, straight ridges that can stretch from hundreds of kilometers, often running parallel to the prevailing wind direction. Parabolic dunes. Parabolic dunes are U-shaped dunes with an open end facing upwind. They are usually stabilized by vegetation and occur where there is abundant vegetation, a constant wind direction, and an abundant sand supply. They are commonly found in coastal areas. Importance of studying wind erosion. Wind erosion forms dust storms. These dust storms have significant effect on agriculture, the environment, the economy, and human health. Agricultural impact: the loss of fertile topsoil reduces soil productivity, leading to lower crop yield and damage to young seedlings, ultimately threatening food security. Environmental impacts: dust storms contribute to air pollution, causing reduced visibility and respiratory issues. They also influence climate change by altering atmospheric conditions and reflecting sunlight. Economic impacts: the loss of agricultural productivity results in financial strains on farmers, while infrastructure damage and the cost of dust mitigation increases economic burden. Human health: fine dust particles can cause respiratory problems, eye irritation, allergies, and increased stress, particularly in vulnerable populations. These combined effects highlights the need to study and manage effectively soil conservation and dust control. Regions prone to wind erosion. Wind erosion occurs in areas with loose dry soil and minimal vegetation cover. The most vulnerable regions include desert and arid regions, the Sahara Desert, Arabian Peninsula, and Australian outback experience intense wind erosion due to extreme dryness, sparse vegetation, and frequent sandstorms. Semi-arid regions: areas like the Sahel region of Africa and parts of Great Plains in the US face periodic wind erosion, especially during droughts when vegetation cover is reduced. Agricultural lands: unsustainable farming practices such as overgrazing and excessive tillage make farmlands prone to wind erosion, leading to soil degradation and loss of fertility. Effective land management and conservation practices can help mitigate wind erosion in these regions. Mitigating wind erosion. Wind erosion can be effectively controlled through various land management practices such as windbreaks, planting trees or shrubs to reduce wind speed, conservation tillage, minimizing soil disturbance and leaving crop residue on the surface, cover cropping, planting crops to protect the soil during fallow periods, proper grazing management, preventing overgrazing and maintaining vegetation cover, irrigation management, using appropriate irrigation techniques to maintain soil moisture. These strategies collectively improve soil conservation and land susceptibility. Effects on environment. Wind erosion's most devastating impact is on the environment, leading to far-reaching consequences for ecosystem and human well-being. These are loss of fertile topsoil, impacting plant growth and food production; dust storms that reduce air quality and harm human health; desertification and habitat loss, threatening biodiversity; damage to vegetation causing climate change; sedimentation of waterways harming aquatic life. The environmental damage caused by wind erosion can be long-lasting and even irreversible, affecting future generations. At the end of the presentation, these are self-assessment questions. Go through each question carefully. Answer these questions based on the understanding of the topic. Review any concept you are unsure about. The questions are: describe the processes of deflation, abrasion, and attrition in wind erosion. How do these processes contribute to overall shaping of the landscape? Explain how wind velocity and particle size influences the rate and type of wind erosion. Wind erosion can have significant environmental economic impacts. Discuss how do human activities such as agriculture, deforestation, and urbanization contribute to accelerated wind erosion. Explain the relationship between wind erosion and desertification. How does wind erosion contribute to the expansion of desert? Thanks for joining this lesson on engineering geology today. Hope you found this presentation informative. Now don't forget to like and subscribe the channel Dr. A Classes for more engaging lessons on core subject of civil engineering.